In 1928, Graham studied the diffusion rates and proved experimentally that the rate of diffusion of a gas and the density of the gas are related with each other. A gas having lower density diffuses at a higher rate. If the rate of diffusion of a gas is R and its density is D, therefore R is proportional to 1 upon square root of D. This relation is known as the Graham's law of diffusion. The law states that under identical conditions of temperature and pressure, the rates of diffusion of different gases are inversely proportional to the square root of their densities. The molecular weight of a gas can be determined by measuring its diffusion rate. Suppose the rates of diffusion of gas 1 and gas 2 are R1 and R2. Their densities are D1 and D2 and molecular weight are M2 and M1 at the same temperature and pressure. According to the law of diffusion, using equation R is proportional to 1 upon square root of D, we can write R1 upon R2 is equal to square root of D2 upon D1. The density of a gas D is directly proportional to the molecular weight M of the gas. The ratio of densities of different gases measured at the same temperature and pressure is equal to the ratio of the molecular weights of those gases. Therefore, R1 upon R2 is equal to square root of M2 upon M1. Thus, the rate of diffusion is equal to volume of gas diffused upon time taken for the diffusion. Therefore, equation R1 upon R2 is equal to square root of M2 upon M1 can be written V1 upon T1 upon V2 upon T2 is equal to square root of M2 upon M1. Now, if T1 is equal to T2, V1 upon V2 is equal to square root of M2 upon M1. But if V1 is equal to V2, then T2 upon T1 is equal to square root of M2 upon M1.